Opposite sides are parallel. We've already covered that twice. Opposite sides are congruent. So parallelograms, rectangles, and rhombi now all have those properties. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. Okay, nothing new there. They're all the properties that we went over yesterday. They also apply to a rhombus. Now, these are the new ones. In a rhombus, all sides are congruent. All sides are congruent. The picture is already marked that way. Now, let's put some actual measurements on there so that it sinks in a little bit better. Let's say that if I know one of those sides has a length of 5, all of those sides have a length of 5 because the sides are congruent. The diagonals are not congruent, they are perpendicular. Now, that is also already expressed there on the diagram. You see the right angle notation there, but let's just kind of re-emphasize it to ourselves. All of those angles there in the middle are 90-degree angles. So I'm going to label 2 of them with 90, and then I'm going to label the other one with the other little right angle square there. Okay, so all those, the diagonals meet and are perpendicular, so all those are 90-degree angles. And the last property is that diagonals bisect opposite angles. The diagonals bisect opposite angles. So this is new, okay? In parallelograms and in rectangles, those angles where the diagonal came in, it did not cut them in half. These are cut in half. So let's say that this angle up here is 60 degrees. Then this one is also 60 degrees because that angle up there in the corner has been cut in half. So then this is 30, and this is also 30. So then, while I'm labeling, go ahead and label all of them. Opposite angles are still congruent. So if the one in the top left is 60 and 60, then the one in the bottom right is going to be 60 and 60. And the same thing for the top right. It's going to be the same as the bottom left. Opposite angles are congruent. And consecutive angles are supplementary. If I add up 30, 30, 60, and 60, I'm going to get 180. Okay, so those are all from either the properties of parallelograms or specifically the properties of a rhombus. Okay, so let's apply this. Let's look at problems 5 and 6. Find the missing measure for the rhombus W, X, Y, and Z. So XY, let's see here. XY is the side on top. Well, for a rhombus, all of the sides are the same. So go ahead and label them all. Go ahead and label all of them 27. So XY is, of course, 27 inches. Okay, let's see here. WP. WP is half of our diagonal there. The other half of it is labeled with 21, so it is also 21. Okay, then PZ. PZ is the other diagonal. It's half of the other diagonal. Now, the diagonals are not congruent. Okay, it's a little bit harder to tell in a rhombus because the sides are all the same length, so they're pretty close, but that diagonal from WY is still longer than the diagonal from XZ. So, PZ is not, but what we do know about a rhombus is we have right angles here in the middle. So what we have, let me pull it out so that it's a little bit more clear. we have a right triangle. 27 is here, 21 is here. We are looking for that part right there. 27 is the hypotenuse. The right angle always points to the hypotenuse. So we are looking for a leg. I left the right triangle stuff up over there on purpose. Okay. The leg is equal to the square root of the hypotenuse squared minus the leg squared. Square root 27 squared minus 21 squared. 16.97. Normally, I would not round that up, but being 9.7 there, I am going to round it to 17 because it is so close to 17, and the instructions didn't tell me what to round to. So if that was like 16.23, I would do 16.2. Okay, but because it's so close to 17, just go ahead and round it up. If we were rounding to the nearest tenth, the 7 would round the 9 up to the nearest whole number. Okay, so let's look at our angles now. The measure of angle XZW. So X to Z to W. So we are looking for this little piece right here. Well, what is that property that you can see right there? Diagonals bisect the angles. So I'm talking about the other half of this angle, and the other half of it's already labeled with 51. So this half is also 51. Okay, so next one, XWZ. X to W to Z. That is the whole angle right here. Now, the only angle that I know anything about is the angle right beside it. And the angle right beside it, we call that a consecutive angle. Consecutive angles are supplementary. So the whole angle at W plus the whole angle at Z is equal to 180. Well, what's the whole angle at Z? Part of it's 51, so the whole thing is 102. So 180 minus 102 is 78. That is the whole angle at XWZ. Okay, last one, ZYW. Angle ZYW. Z to Y to W. We're talking about this little piece here. Well, that is opposite the angle that we just found. So the angle that we just found was 78 down here. So the whole angle at Y is also 78 degrees, but we just want the half of it. So 39. There are other ways that you could have found that. You could have used consecutive angles here as well. So sometimes there's more than one way to get to the answer, but I think that was the easiest one there. All right, let's look at number 6. We've got a rhombus again. Find the measure of FGE. Remember, we always want to highlight what the question's actually asking for. Okay, F to G to E. We're looking for that half angle at G. We don't have anything labeled there. What do we have something labeled up? We have the angle at F. It has 2 expressions there. They're pointing to the individual half angles. That angle has been bisected, so those are equal to one another. They are equal to one another, so we set them equal. We solve. So we get 3x minus 49 is equal to negative 7. We add 49. 3x is equal to 42. Divide by 3. X equals 14. We're still not finished. Yes, we've done a lot of work already, but that's not it. It didn't ask for x. We wanted angle FGE. So, FGE is beside of the angle that's been labeled. So how about we start by plugging this in. 5 times 14 minus 7. $63 degrees. We got 63 right here. We got 63 right here. Still not what we're looking for. So that whole angle is what? 126? 63 and 63, 126 for the whole angle F. F and G are consecutive. Or you know what? There's an easier way to do it. Now that we have that 63, don't forget, that's a right angle right there. So look at the little triangle. We know 90, we know 63. So 180 minus 90 plus 63. Now, I could have done what I started to describe, which was a little bit more work than I really had to do. 27 degrees. And yeah, unfortunately, there's no magic formula. I can't tell you exactly how you have to approach each of these problems. You really just have to kind of take a step back, look at what information am I given, what information are they asking for, and what do I know about this shape? Okay, what do I know about these properties that will help me out? So I overlooked for a second the fact that the diagonals are perpendicular. So I've got right angles in here, so I've got a little right triangle. Once I find that 63, it's really easy for me to find this angle that I'm actually looking for. Okay, any questions? Okay, let's look at squares. Okay, squares are getting more specific than rectangles, more specific than rhombi. Okay, they have all of those properties that we have talked about so far. So opposite sides, still parallel. Opposite sides, still congruent. Opposite angles, still congruent. Consecutive angles, still supplementary. And diagonals still bisect each other. So that's all parallelograms. All those properties, the ones that we've talked about 4 times now. Okay, now let's talk about a property of rectangles. All right angles. You know this already. You know that squares have all right angles. Okay, but that's a property from rectangles. All sides are congruent. That's a property from rhombi. Diagonals are congruent. That came from rectangles. That was not true about rhombi, but it is true about rectangles. The diagonals are congruent. The diagonals are perpendicular. That's from rhombi. And diagonals bisect opposite angles. That's also from rhombi. So this one, and this one are from rhombi. Okay, so nothing new when it comes to squares. Squares are just a combination of rectangles and a rhombus. All right, so let's use it. If BCDE is a square, find the missing measures. So CE, let's see here. What's labeled on our picture? C to E is this whole diagonal, but a square is a parallelogram, so our diagonals are cut in half. They've labeled C to F, that's 8, so from C to E is 16. From B to C. From B to C. Well, the only thing that they told me was that diagonal. Now, I think it's pretty clear that the diagonal and the side are not the same length, right? So there's got to be something that we can do here. Well, a square has all right angles in the corners. So I'm going to pull this out. This is B, C, and E. I know from C to E is 16. I don't know anything else other than this is a right triangle. Now, I do know something else though. These angles at C and E are bisected. So they were 90, they're cut in half, so half of 90 is 45. I want this side right here. Guess what? We're going to use some trig. Okay, so in relation to our 45-degree angle, we've got opposite, adjacent, and hypotenuse, right? Those are our three options for our sides. X is across from 45, so that's our opposite. Is 16 adjacent or the hypotenuse? The hypotenuse. It's across from the right angle. If you struggle with identifying that, use the little square. It points right to the hypotenuse every single time. So 16 is our hypotenuse. Opposite hypotenuse is sine. So the sine of our angle is equal to the opposite, we don't know it, over the hypotenuse, 16. If we're solving for x, we're dividing by 16, so the opposite is to multiply by 16. So 16 sine of 45 degrees is equal to x. Use your calculator. First of all, make sure it's in degree mode. If you're in a habit of resetting your calculator, that will change things. So put it in degree mode. 16 sine 45, 11.3. 11.3 is the length of side BC there. Okay, let's go to the angles. CFD. CFD. A square is a rhombus. A rhombus, the diagonals meet at right angles. So CFD is a 90-degree angle. DBE. D to B to E. We got a right angle down there in the corner at B, but we're just talking about half of it because those diagonals are bisected. So that's 45 degrees at DBE. So interesting thing, observation here. Typically, the sides have been the easiest things to figure out for parallelograms, rectangles, a rhombus. The sides were easier. The angles were a little bit more challenging. I feel like that relationship's kind of reversed here. We had to do more work to figure out that missing side than we did to find those angles. The angles are pretty simple when it comes to squares. They're either 90 or they're 45. It doesn't get much more complicated than that. Okay, let's look at number 8. If QRST is a square, find QS. So we've got a side marked there. So that's good because it's a square. I can mark all the sides with the same length. What do they want me to find? QS. Well, I'm kind of in the same boat again, though. But I don't have to use trig this time. I got a right. I know the legs. Leg squared plus leg squared equals hypotenuse squared. 21 squared plus 21 squared equals x squared. Square root. And I'm going to have my answer. $29.7. Notice I did not round that to 30. It didn't round up to 30. 29.7.